Okay, the first strategy that I'm going to show you is using base 10 blocks. So for base 10 blocks, we have hundreds drawn as squares, tens drawn as sticks, and ones drawn as dots. So if we're adding, let's say we're adding 457 plus 265. We're going to draw out 450, so 100, 200, 300, 400, 10, 20, 30, 40, 50, and then 1, 2, 3, 4, 5, 6, 7. And then we're also going to do 260 and 5. Okay. Then I noticed that my ones and my tens, my ones, the 7 and the 5, there's more than 10 ones. So I'm going to take 10 of them, and then that's going to create another 10. So I'm going to essentially put these together and make a new 10. Because I had 12 ones over here, so the 10 from that 12 becomes a 10. I also noticed that here I have 10 tens, and 10 tens I know is a group of 100. So then I move that over. So now I have 1, 2, 3, 4, 5, 6, 7 hundreds. I have 1, 2 tens, and I have 2 ones. So my answer is 722. I could also write it like this: 700 over here. I have 20 in this picture, and I have 2 here. If I add that together, that's expanded form 722. For subtraction, I will do the same strategy, but with a different equation, obviously. Minus 346. Okay, so 531 minus 346. For this problem, I'm only going to draw the first number. And this was a big misconception with students, is they want to draw both numbers, but I'm only going to draw 531, and I'm going to take away 346. So I can take away 300s. I cannot take away 4 tens because I only have 3 to cross out. So now what happens is, if I don't have enough tens, I take one of the hundreds and I break it into 10 tens. Essentially doing the opposite of what we did here with putting 10 tens together to make 100. I'm breaking the 100 into 10 tens. Now I can take away 4. Okay, and you can just slash it through, or you can cross it out. And then I look at the ones. I don't have enough ones to take 6 away. So I'm going to take one of the tens and break it. Now I can cross out 6 ones. 6. And then I see what's left. I have a group of 100. I have 10, 20, 30, 40, 50, 60, 70, 80. And I have 1, 2, 3, 4, 5. So I have 185 left over. This is another strategy that goes along with place value. As long as students can pull apart the hundreds, tens, and ones and add them together, all they're doing is adding horizontally rather than adding vertically, like the stacking strategy. So we're gonna pull out the hundreds, 400 and 200, add it together, and then the tens, it's 110, and then 7 plus 5 equals 12, and then we'll put all of these together. Now, if the students want to put like 600 plus 110 together first and then add the 12, that's fine too. If they want to move these to where they're supposed to be, they can do that as well. There's no real exact right way to solve these or to use these strategies. Students can kind of put their own spin on them. It's whatever works best in their brain. So that's how I would use place value to help me solve this problem. Now, if I'm doing subtraction, with this strategy. It looks a little bit different. 31 minus 346. For this one, I would still pull out the hundreds, subtract them first. I get 200. And then I would do 30 minus 40, but I need to notice that that's not gonna work. I cannot do 30 minus 40. What I can do is take one of the hundreds that I have and pull it down here, leaving me with 100 up here. 130 minus 40 is 90. Now, if students are having a hard time with these equations, then we might need to go back a few steps, because they really should know what 13 minus 4 equals. If they can do 13 minus 4, then they should be able to do 130 minus 40. Then we'll do 1 minus 6 because of the ones. And once again, we should notice, oh, we cannot do that, but I can bring a 10 down, and then that would leave me with 80. So then 11 minus 6 is 5. I put those numbers back together, and I get 185. The next strategy that we're going to use is my favorite strategy. We're starting to move away from base 10 blocks. So base 10 blocks is really only used to really check their work at this point, and if they get stuck. Now we want them to start using place value strategies, like expanding a number and stacking them on top of each other, which looks a lot like the algorithm, which they will learn in 3rd grade, but we want them to learn this strategy before they move on to the algorithm. So if we'll use the same equation. Okay, we're doing addition first. What I'm gonna do is I'm gonna expand both numbers into expanded form. So the value of the 4, the value of the 5, and the value of the 7. And I'm gonna write them next to each other with some space in between. So 457. And then I'll do the same thing here, making sure that I stack them on top of each other using the place value. Ones, tens, hundreds. Then all I'm gonna do is add straight down, just like the algorithm, starting in the ones place. So 7 plus 5, we'll do that one first. 7 plus 5 is 12. I know that because 5 plus 5 is 10 plus 2 more. 50 plus 60 is 110, because 50 plus 50 is 100, plus 10 more is 60, and then 400 plus 200 is 600. And then I'm not gonna add them together until this looks like expanded form. The ones, the tens, and hundreds are all, it's only ones here, only tens here, and only hundreds here. But I have a 10, and I have 100. So I say that we need to send them home. So the 10 needs to go to the tens place, the 100 needs to go to the hundreds place. So then I rewrite it down here. So 600 plus 100 is 700. 10 plus 10 is 20, and then I have 2 left over. And then I would put my answer over here, 722. This is my favorite because it then allows them to progress to the algorithm, which would be when we do it like this. This is the algorithm that they will learn how to do this in 3rd grade. But if they can understand this, then this will make so much more sense. So for subtraction, if I do 531 minus 346, I'm going to expand it exactly the same way, making sure that I keep them stacked on top of each other, and I'm subtracting. So this time I'm going to do 1 minus 6. Now a lot of my friends want to just switch it and do 6 minus 1. We cannot do that. We have to borrow. Well, I can go ahead and borrow, so I have 30 here. If I borrow a 10 and I put it here, then that makes 11. Then I have 20. So I can do 11 minus 6 is 5. Okay, and then can I do 20 minus 40? No, I cannot. So I need to borrow 100. So if I borrow 100, that means I have 400 left over. I can do 120 minus 40, that's 80. okay? And then I can do 400 minus 300, that's 100. And then I put it back together. So even though we're subtracting, we still have to put the hundreds, tens, and ones back together at the end. So that would be 185. Okay, so this is exactly what we're doing in the algorithm, but this is showing the place value, and the value of the 3 is not a 3, it's really a 30. So then if you give the 1 a 10, it's coming out of the 30. It's not really coming out of the 3. So that's why we really stress this strategy before we get them into this strategy. The last strategy that I want to share is the most abstract. It is the number line strategy. So if I'm using this equation, I'm going to draw just an open line. And I'm going to start with 457 because it's my biggest number. And I'm going to jump 265. Okay, so I'm going to go ahead and jump 200. So 457 plus 200 would be 657. Then I'm going to go ahead and do my tens. But what I notice is I have a 50 here. I know that to get a nice even number, I can jump 50 more to get to 707 and then add the other 10. It's just faster for my brain to do 50 plus 50 than it is to do 50 plus 60. So here's your 60 right here. I just split it up. And then I'm going to add my 5 ones. But once again, I notice, oh, there's 7. I know that 7 and 3 are best friends. That's what we call that when it makes 10. They're best friends with each other. So I can get to 720. And then all I have to do is add 2 more to get to that 5. 722. So there's the number line strategy. Now, they do not have to start with hundreds. They could hop the 5 first, or 3. They could hop 3 first to get to 460, and then hop 200, and then hop the 40, and then they could do so many different things with this strategy. But what's really important here is the whole point is to add friendly numbers and to get to friendly numbers. That's the whole idea with that strategy. With subtraction, there's actually some different things you can do. You can do just subtraction. You can start with 531. Now I'm going to start here this time and go backwards, because when a number line, smaller numbers are here, bigger numbers are here. And then we will take away 346. So I'm going to take away 300. I'm going to get to 231. Then instead of taking 40 away, I'm actually just going to take 30 away to get to 201. And then I'll take away 10 more to get to 191. Then I need to take away 6, but I'm not going to do that. I'm going to take away 1 to get to 190. And then I'll take away 5 to get to 185. So once again, breaking numbers apart to get nice friendly numbers. But in the end, this up here should add up to that number, and then this should be my answer. You could do it like that, or you could flip the problem so that it's this. That's a 30, 531. So I could start with 346 and try and end at 531 and see how many hops it takes to get there. So if I'm at 346, and I like to get to a nice friendly number first, so 350. Okay, then I need to get to 500. So, well, I need to get to at least 400. So let's add 100. So we're going to get to 450. And then I can add 50 to get to 500. And then I can add 30 to get to 530, and then I can add 1 to get to 531. Now your answer is here. So 50 plus 30 is 80, 4 plus 1 is 5, and then we have our 100 over here. So that is 185. This is very abstract. A lot of students do not use this, but the ones that do love it and use it often. So I just wanted to expose everyone to it so that they understand what their students are coming home with. If they come home with this strategy and it doesn't make sense to you, you can refer to this. And there's so many variations. If you ever need help with any of these or have questions, please reach out and ask.